Now in the first optimization problem we looked at together, you remember the one about the ball? We were given the function that modeled that particular situation. Now the next two examples we're going to look at together, we're going to have to create the function ourselves from the information given in the problem. So for our next example, we're going to look at this. We're told that the difference between two numbers is 10, and we're asked to find out what the minimum possible product will be for those two numbers. Now what I find helpful personally is to look at some specific pairs of numbers to get an idea about what kind of numbers might produce the minimum product, so that when we actually solve the problem algebraically more formally, we'll have an idea of whether or not our answer seems reasonable. Now what I've done is to choose some numbers at random to fill in for the value of the first number. And I began with the number 20 and then decreased the value of the first number to see if we might notice any kind of pattern eventually. So if the first number is 20, then all we need to do is subtract 10 from that to get the second number because we know the difference of the two numbers is 10. So 20 for the first number, 10 for the second number produces a product of 200. If the first number is 15, then the second number would be 5 and the product would be 75. Now if the first number is 12 and the second number is 2, the product will be 24. If the first number were 2, the second number would be negative 8 and the product would be negative 16. And now if we jump into the negative numbers for the first number, if we choose negative 3, the second number would be negative 13 and the product would be positive 39. Now as you look at the numbers in the table here, we can probably observe, and I'm sure you have already, that it will seem reasonable for us to get the minimum product that one number will have to be positive and one number will have to be negative. So if we zero in on this particular row right here, of the numbers we've chosen, the negative 16 would be the minimum product. Now if both numbers are positive, clearly the product will be positive, and if both numbers are negative, the product will be positive. So when we solve the problem formally, we should expect to find one of the numbers being positive and one of the numbers being negative. So we'll next represent the first number by using the variable x. And to get the second number, then all we need to do is subtract 10 from that. And then the product of those two numbers will be x then times the quantity x minus 10. So what we'll do next is define those variables a little bit more formally, and then we'll create the function that we need. So we'll state in words then that we're going to let x be the first number and x minus 10 be the second number. Now since it's the product that we would like to minimize here, we're going to let y represent that minimum product. So the function then that will model this particular situation becomes y is equal to x times the quantity x minus 10. And now if we multiply through, we have y is equal to x squared minus 10x. Now we know that the graph of that particular quadratic function will be a parabola that opens up. And so the key then to answering the question posed by this problem will be to find the coordinates of the vertex, because we know that the y value of the vertex is going to be the minimum value of the function that we've created here. So that will then be the minimum product. So let's next find the vertex, and we're going to use the formula to find the x coordinate, which is negative b all over 2a. And our b value is negative 10, so we have the opposite then of negative 10. All over 2 times our a value. So we have then 10 divided by 2, or the x coordinate of the vertex, is equal to 5. Now to find the y coordinate of the vertex, we need to substitute that value into the function. So we'll have then 5 squared minus 10 times 5, which is 25 minus 50, or negative 25. Now we can see that the minimum product of the two numbers is the y-coordinate of the vertex, which is the negative 25 that we just computed. Now what two numbers actually produce that minimum product? Well, we know that the x-coordinate gives us the first number, which is 5. So if x is equal to 5, then x minus 10 will be equal to 5 minus 10, or negative 5. So what we'll do then is to end up by writing a sentence answering the question that was posed. So we state then that the minimum product is negative 25, and the two numbers that produce the minimum product are 5 and negative 5. And as we determined at the beginning of the problem when we looked at the numbers in our table, we anticipated that one of the numbers would be positive and one would be negative, and that is indeed the case.